Oh my God, Jeff. All right, little tripod dude, you're drunk. Okay, there we go. So cosine, law of cosines. Has everybody got this? Oh shit. Has everybody got this sheet here? It's coming. No, it's not, Jeff. You have to turn that on. The one that says law of sines, law of cosines?
Yes.
Okay. Ooh.
I need the sign page.
Oops, sorry. So we did an example yesterday down here. So let's try another one out. Sorry? Oh, you probably don't. Mm-hmm. So just to keep myself straight, I'm going to steal a problem from the book. Yeah. There we go. Okay, beautiful. So let's try this. What if I had a triangle where I know these sides, sure, not drawn to scale, poor little dude. And I'm going to say this is angle A, B, C. One. So I just know the sides. So really obviously, why can't I use law of sines?
Because you can't make it full ratio.
Can't make a full ratio. I love it. Okay. Anyway, I should remember back when I learned this stuff, I wish they would have just said that. That makes so much sense. I think, what were you about to say, Isabella? Well, this is no A. I don't know any A's, right? This is SSS. This is the snake one. Now, so which angle should be the biggest?
C.
Because it has the biggest mouth, right? So let's solve for C first. How the shit am I going to do that? So we already identified it's not a law of sines problem. So it's obviously a law of cosines because whenever one doesn't work, the other will work. Yeah, the first one's involved. That's the only one that involves angle C, and I know everything else in there, right? So this just becomes a plug and chug problem. So let's label these. This is side C. This is side A. This is side B. So now I can just throw stuff in. C squared equals A squared plus B squared. That sounds familiar. Minus twice A times B times cosine of C. Does anyone remember why law of cosines will not return what's called an ambiguous case? It won't return a possibility for more than one triangle. In this specific case, there's only one damn triangle, right? But in general, it won't. Does anyone remember why? Inverse cosine goes from what to what? 0 to pi. That covers all the options. There's no reference angles it could spit out. Sine could be giving us just a reference angle. That's why it opens up to possibly more than one triangle. Okay. Now this is just a bunch of plug and chug crap, right? Now you got to be careful about order of operations. I always get students suddenly forget about order of operations. So let's see if we all get the same thing. Try to solve that. Bum, 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 bum. Let's do degrees just to be crazy. No, Jeff. Gummit. Gotta redo the whole damn thing. Does anyone think they have the answer? Yes.
So 156.05?
No. As long as I plug my stuff in right. Let's see. Yeah. So that's not quite right. Yeah. Nobody else? All right. So here.
Can we watch you input it because I did?
Yep. I'm totally going to do that right now. Here we go. So so what I need to do is I need to subtract those. Right? So I'm going to do 25 squared. Jeff, you're going to do 25 squared minus 20 squared minus 18 squared. So now where am I? I got negative 99 equals negative 2 times 20 times 18 times cosine C. Right? So the big mistake people make is they like combine all this stuff. How can you do that shit? You can't.
Wait, why did you subtract them? Because eventually you're going to have to move.
No, just to move them over. If I get rid of these, right, put that over there, I just have this part left, and now I'm getting my cosine C by itself, right? Yeah. So I'm trying to solve for this. I'm trying to get this term by itself, so I want to get rid of this stuff. Now what do I do? Well, sure, okay. Negative 99 equals
Negative 720.
negative 720. And then, of course, you divide. So I get 99 over 720 equals cosine C, and then I take the inverse cosine. Kick ass. Die. So I get C equals inverse cosine, 99 divided by 720. Is that all right? How would I know really quickly if I got like 11 degrees? That was wrong.
Because C is
C's the biggest. So that's one reason why I do that one first, because then I can tell really quickly if it's wrong. 82 degrees very much is possible. That makes sense. So now how do I get the other two?
Well, now you
Well,
have
now
at
you can
least one
complete
to C.
Now you could do what? Sorry?
Now you can.
You could use law of sines. You just have to be careful because, again, it could give you a reference angle, not really the answer, right? So it's not a bad... You can do that. Just, make sure the answer makes sense. Or I could just do another one of these. The great thing is, once I've done this twice, once I get one more angle, I don't have to do this again, right? Once I got two angles, I'm golden. So let's see. So let's see if you guys want to try this again. So now let's use the second dude. Let's figure out what angle A is. 20 squared equals 20. Let's see. We can do it in the same order, Jeff. 18 squared, 25 squared. Cosine A, scheisse.
Hey, Jeff,
Yes.
that's not a possible triangle,
Why?
because a squared plus b squared does not equal c squared.
All right, guys. Guys. Okay. What kind of triangle is that true for?
Oh, a right triangle.
So if
That's
that is
not a
an
right-
that is an impossible right triangle. Well, I didn't say it was right.
Oh,
Yeah.
my bad.
No worries. I can totally understand why that would be confusing as hell. Okay. You guys feel a little better about solving this one?
Yeah.
Okay. Dadgummit.
That's why you have the law of cosines.
There you go. Yeah, yeah, exactly.
Okay. A little slow on the uptake.
No, you're fine. This is definitely not intuitive stuff. I think we would all agree with that. Anybody want to hazard guess as to what that is?
Is it
There it is. Cool. What was this? This is really 82.1. Be a little more precise, right? So 82.1 degrees for C, 52.41 degrees for A. So then what's B? Kick ass. And why does that line up with what we expect? C was the biggest. What angle should be the smallest? B, because it has the smallest mouth. And sure enough, bam, bam, bam. So that doesn't tell me that everything I did is exactly right, but at least it rules out that I made some big mistake, right? Okay. As always, I love some facial expressions out there. Yes?
When we're finding angle A, do we also have to take the inverse of cosine?
Oh, totally. Yeah. All right, sorry. So here's basically my work. 20 squared minus 18 squared minus 25 squared. And then I divided by negative 2 times 18 to 25. And then I did inverse cosine, of course, because at that point I got cosine A equals blah, right? So if I subtract this stuff over and then divide by this stuff, I'll have cosine A equals a number.
Yeah.
And then I've got to take an inverse cosine.
So at like negative 549 divided by negative 900 equals cosine A, and then we take this.
Inverse cosine.
Okay.
Yep. All right. So here's what I really want you to understand something I said earlier. SAS. Who knows what that means?
Angle, side angle.
Sine angle sine.
Side angle, side down.
Right? Here's what I mean by, I've seen books that teaches you have to memorize SAS is the law of this, and it says is the law of this. That's so much bullshit. How do we determine? We rule out law of sines. What's the first thing we look for to tell which one I'm going to use?
If you can complete.
If you can make a complete ratio. If you can, sines. If you can't, it's crazy. You don't have to bring in the freaking ASA and SSA and whatever crap. Yeah.
What do you mean completing a ratio?
All right, good. Law of sines. It's this dude. So I must know, whatever they tell me, I must know an angle and a corresponding side for the angle somewhere in what they tell me. That would be a complete ratio, correct?
Mm-hmm.
So here, the problem we just did, I would know A, B, and C. Little a, little b, little c. I could not make a complete ratio. Therefore, I can't make an equation with only one unknown. Does that make sense? No. Shit. Here. I can make a complete ratio with the A's, correct? Yes?
Yes.
And then I can set it equal to that incomplete ratio for the C's. And then I only have one unknown.
Okay.
Big ass C. I mean, sorry, little ass C.
Okay.
Do you guys see that? That's what I mean by can you complete a ratio? If you cannot complete any of these, it's impossible to set up an equation with less than two unknowns.
Okay.
Yes?
My question was, what if they only give us like a degree for angle A, and that's it, only one? That makes sense.
Oh, like this problem.
Okay, then never mind.
Okay.
Yeah.
So yeah, definitely. In fact, the last problem we did had no angles given to me. Yeah. Okay. All right. So normally after some of the other stuff we've done before this, and I'm not saying you should totally feel completely comfortable with this, but normally students are a little bit better with these. Because again, they're a little more constrained. They're a little more recipe-ish, which I don't blame you for enjoying those kind. So you can quickly tell which law should I use. Right? I don't have to memorize SAS and all that bullshit. There's no reason to. Because mathematically, I have a way that makes a lot more immediate sense. Yeah.
So the law of cosines is a lot more complicated.
Yes. But if you do this, watch. What's that?
That's
Pythagorean theorem. And then that is a messy thing. And we should expect it to be messy because it's trying to make the Pythagorean theorem work for a non-right triangle. So on that level, I really just desperately hope anybody out there is mildly like, oh, that's Pythagorean. That's an adjustment if it's not a right triangle. That's so freaking beautiful. You don't all have to agree with me. All right, I'll stop. Okay, so today we desperately need to do something.
We're gonna learn the law of tangents.
You want one? Do you want the law of tangents? That's not in our curriculum, but I could teach you.
No.
Okay, okay. So, let me ask you this. How much time do I have? So much time.
This is more complicated than the other two for some reason.
I'd rather, okay. So guys, if I wanted to locate, guys, if I want to locate somebody in a row, right? I want to find, I'm sorry, I'm just picking you for some reason. If I want to locate somebody in a row, you could tell me, of course, how far to move this way, and then how far to move into the row, correct? You tell me how many rows to step, so that's like the x-axis, correct? And then you can tell me how deep to go in, that's like going down the y-axis, you with me? Another way to find a point in space. So let me do one, I'd rather use the board, so. Exactamundo. So I could find a point, so here's a point, that's crazy. I can find that point, and let's say I start down here. Yes? You with me? Guys?
Yes.
So I can find that point by saying go over this far and go up this much, and that's our normal XY coordinate system, yes? I could also say, all right, I'm standing here, I'm standing on the thing. What's a better way to do this? Yeah, okay. Let me do this again. So I want to make my way to Mike. So you can either tell me how far to move on the x-axis and then how far to move on the y-axis, correct? Okay. Or, here I am at the origin, facing the x-axis, that's 0 degrees, correct? Instead of telling me how far to move over and up, you can just tell me which direction to face, and then how far to walk, correct?
Yes.
Okay,
And
so,
the direction is the angle.
exactly.
Okay.
So if I turn, I'm turning through an angle, and then how far I walk would be the radius. Does that make sense?
Yes.
So finding points in space using XY coordinates is just one option. And it's the one you're the most familiar with because it's the one we use all the damn time. But we could have totally just never even done that shit. From the beginning, we could have just said, no, just turn by. So if I want to find this point, I would turn by a certain angle, and then I would walk a certain distance, and I'd find that point, right? Okay. Or I could do X, Y. So let me do this. Here's X, here's Y. Okay, let's do this. Let me make sure I'm getting all this. Yes, okay. So that makes sense. So I could find that point by going over and up, like we always have. Go away, point, sorry, point, not you. So that would be the point XY. Or I could say turn through an angle and go a certain distance. Now, can anyone tell me in terms of R and theta what that point is? You totally can. We know this shit. Huh? No. I have no way of knowing if that's pi over 4 or what that is, right? It could be anything.
Oh, it's cosine.
Yeah. So what's cosine theta, for example?
X comma y.
X, no, come on.
Oh, over y.
No.
Over y.
R.
R.
So that means X is
R cosine.
R cosine theta. So what do you think Y is? She cut to the chase.
Cosine.
R sine theta, come on. X likes cosine, Y likes sine. So remember, a while back I told you this. Sine theta and cosine theta are kind of like the part of R that lies along X or Y. So cosine theta is the part of R that lies in the X direction. Sine theta is the part of R that lies in the Y direction. Okay, maybe. So what we've just determined, and actually this is old news. We knew this shit. We're just looking at it in a different way now. Instead of just purely looking at it as angles and triangles, I'm looking at it as a way to find a point, which we haven't looked at it that way. Yes?
So how did we know it was cosine?
For which one?
For the first one.
I just picked something. So what's sine theta?
Oh, okay.
Y over R, which leads to
Yeah.
this, right? I just had to start somewhere. Yeah. I needed a relationship between theta and stuff. Now, I could have used, go ahead.
Forgive me, I'm probably gonna ask questions that I should have known a while ago because I haven't been here, but I'm confused what rearranging into those two other ones does. Like, what does that give
Well,
you?
that's new to us. That's semi-new to us.
Okay.
What does that do for us? We're getting there.
Oh, okay.
Okay. Let me, before I do what I was about to do, I'll do it later. So what does this mean? If I have the point 3, 4, I can now figure out, so that would mean telling somebody to walk 3 steps east, 4 steps north. Are you guys all with me? But what if the guy's, I don't want to walk that far. I'll just walk straight there. So what would be as the crow flies? You guys all cool with that phrase?
Yeah.
Is that still out there?
Northeast?
Huh?
Northeast?
Sure, roughly.
Okay.
But I want to be really exactly right.
Okay.
And now I've kind of remembering I've gone backwards. So this is what we're about to get to. This would be converting from, oh Jesus, poor little dude. This would be converting from XY to, you ready for this? Yes, you are. R theta. Does that make sense? This is a coordinate
yes.
system based on going left and right, up and down. This is a coordinate system based on turning and then walking. I wish we would have turned these around. It makes more sense, but too bad. This is the way they wanted to do it. Okay.
Walk and then turn.
Exactly. Yes.
So for the equation x equals r cosine theta 3 equals.
Yeah, we could, but we'll get there. We'll get there. I kind of did this a little too early. This would be, what if I told somebody to rotate 61 degrees and then walk 5 feet?
Then it would be.
What would this point be in rectangular coordinates?
It would be.
Well, what did I tell you? What's R?
5,
5, and what's theta?
61.
All right, so to figure out this in rectangular coordinates,
It would be.
I just plug and chug shit, right?
It would be 5 over 6. 5, 61.
Wait, so when you plug in chunks, you use both equations? X and y?
Well, what's the question? I want to know what point I end up at. And doesn't that point have 2 parts?
Yeah.
So I got to figure out both.
Okay. Okay.
So then how would I figure out the x piece of this point? So is everybody with me? If I tell somebody to turn 61 degrees, and somehow they know exactly 61 degrees, and they walk 5 feet, they're going to end up at a point.
Yes.
We could call that point, what would it be like this? We could call that point 5, 61 degrees. But if we're like, oh shit, let's translate that into, it's the exact same thing as somebody saying, well, you have to go 7 meters. And for most Americans, you go,
7.
what the shit's that?
Yeah.
So we have to translate to something we know better, right? So if somebody said, well, you got to go to 5, 61 degrees. Can you turn that into XY, right? So what would it be? What would the X piece be?
5
5 times
cosine
61. You can throw in the old calculator, right? It's going to be 2.49. I don't know.
2.42.
242? Okay. I'm okay with that. And then 5 sine 61 degrees. I don't have a good estimate for that.
4.37.
Thank you. Feet. And it's, well, it doesn't matter. The point would be 2.42, 4.37. Does everybody understand the basic idea here? I could identify a point in space either by turning and walking to it or walking east, going north, right?
Yes.
They both end up at the same point. So of course it should make sense there's a way to translate between both ways of doing it. Just the same way as I could use inches to tell how far I am from somebody, or I could use centimeters. They both represent the same thing, they're just different ways to talk about the same thing.
So the numbers that we just got, the 2.42 and the 4.37, those would be the one where you're going east.
That would be,
and
so
then
this would
north?
be 2.42, and this would be 4.37.
Okay, so that's like how you're, like if you were telling somebody to go
Yes,
and then.
yes.
Those are our new x and y values?
Not new ones, they're just the way to define this point in terms of x and y instead of in terms of r and theta. So this is the same as 2.42 comma 4.37. They're the same thing. It's the same thing as saying, shit, what do I know real quick? Not much, that's too bad. Same thing as saying like 20 degrees Celsius in Canada, and you're like, what? And you go, that's roughly, what, Jeff, you can do it? 36 plus 68. That's like 70 degrees, I can't remember. All right, so you can translate it back into Fahrenheit. They both reference the exact same heat in the air, right? So these both mean the exact same point.
So the 5, 61 degrees is r and theta,
Good.
and then what we just got is x.
Yes,
then
so
we
you
did
could
it
write it as
backwards.
2.4. What do you mean did it backwards?
Because you said we're going to be doing x, y, 2.
We will do that. I just hadn't done it yet.
Oh.
I got this one. I wrote this one too early. We haven't done the reverse. So if I can translate from inches to centimeters, can't I also go from centimeters to inches?
Yes.
Do I do the exact same thing?
No.
I do kind of the opposite, don't I?
Yeah.
Okay. So that's not bad. If they give me r and theta, I can just throw those in. And memorizing these has got to be easy because you've already got the shit memorized. So that's nothing new. Okay, now, how do we go the opposite direction? I guess I can go on the paper now. Let's do that. How do I go the other way? So, if I'm given, let me draw this, I'll do one in general. X, Y. So I'm given an XY point. By the way, I'm doing all my work in the first quadrant, but it really doesn't matter what quadrant I'm in.
You should probably find the angle.
How do I find the angle? So now I'm given XY, I'm trying to find R and theta, correct? So how would I find the angle in this case? What's the relationship here?
It's give me a sec.
It's tangent.
Good. Tangent theta.
Yeah, I'm pretty sure.
We'll get there. Tangent theta is
X over Y. Or Y over X.
Y over X. So like Mike said, right? And then how do I figure out R? Well, you've known how to figure out R forever. What kind of triangle is this?
Right. So you can.
By definition, right? Good old normal, unadjusted Pythagorean theorem, right? So what is R squared?
X squared plus Y squared.
X squared plus Y squared. We normally write it like this without taking a square root because it just looks better like this. You guys with me? But the thing to remember now, here's where things get interesting. Okay, so everybody semi-decent. Again, nothing new. We're just using this in a different way than we have before. So going back to this, let's do a concrete example before I do some other shit. Actually, let's do a little bit different. Let's do one that's not in the first quadrant. So what if I had a point -4, 3? Sure. And I want to know what R and theta are. And of course, theta has to be here, right? Because where does a person always start? Facing east on the x-axis, correct? All right, I like it. So how do you figure out the angle? Well, we got the formula, right?
You would do
Inverse tangent of.
3, 4, 5.
of
Well, we're getting there.
of
We're not there yet.
3 over -4.
Good. So let's see what we get. I think I'm still in. Let's all stay in degrees for the moment. Yeah.
-36.
Now, real quick, is that the right angle?
Yes.
Look where I am.
No.
So again, remember, what's the output for inverse sine? Output for inverse cosine is 0 to pi, which is why it's not going to have an ambiguous case. What's the output for inverse sine? -pi/2 to pi/2. And do you remember how I keep saying tangent goes like sine? The way I memorize tangent is it's small when sine is small. So that relationship keeps going. Tangent has the same output. Inverse tangent has the same output. -pi/2 to pi/2. We're in what quadrant? Second quadrant. -pi/2 to pi/2 is fourth and first. So I really want you to understand, why does the inverse trig functions not just give me the angle I want? Well, how did we even create inverse trig in the first place? We had to chop. We had to chop them. We had to cut their domain down, correct? Remember? To make it invertible to make it 1-to-1 to make it pass the horizontal line test? Yeah.
I don't understand why we're using inverse tangent.
Were you okay up here?
Yeah.
Well, that's now the general way I can go from xy to r theta. Is this true?
Plugging in.
Is this true? This is true no matter what, right? Okay. So no matter what x and y are, this is true. So I'm just using it with the specific x and y.
Or could you use a different trick function?
We don't know. If you figure out what r is first, sure. You could,
Oh, I see what you're saying.
right?
Yeah.
Yes.
So right now, if they're giving me like a reference angle or something.
Totally. So the answer we got is in what quadrant? No, the answer we got
Oh, it's in the first and fourth.
is in the fourth quadrant, correct? Negative 36. So it goes there.
Uh-huh.
So I want,
This, you want the second one.
so let me add
But I thought we wanted to use like
pi.
all the angles.
I'm sorry, 180 in this case. That's right. We have degrees.
We were, and then it went to the fourth.
Sorry?
We were in the second quadrant and it went to the fourth, but we want to get back to the second.
No, 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 no.
Why would it,
Well,
why would it give us an answer?
The answer
before?
it gave us. Okay.
Because that's
All right.
just the.
Because of everything I just said.
Oh, because y is
The
bigger.
answer it gave us is in the fourth quadrant. Does
Uh-huh.
everyone agree with me?
Yeah.
We know
Yes.
our answer has to be,
In the
for
second.
our problem, has to be in the second quadrant. Why is inverse tangent? It's not inverse tangent's fault. We had to chop the frickin' shit it was able to give us in order for the inverse to exist.
Mhm.
You guys remember that?
Uh-huh.
Yeah.
We had to say, no, you can only exist between negative pi over 2 and pi over 2, because otherwise the horizontal line test goes to shit. So it's not
Okay.
inverse tangent's fault. It wouldn't exist if we hadn't. So what does it do? It does the best it can. It's like, here you go, man. It's just a reference angle. I can't get to the second quadrant, whatever.
So it's
Right.
giving you a reference angle in the fourth quadrant.
Yes, because again, inverse tangent, the outputs exist between negative pi over
Okay.
2 to pi over 2. That's all it can give me. So if I'm supposed to be in one of the other quadrants, I just have to work my way over there.
Okay, so it
But if
can't,
it's-
anything can be moved to another quadrant. If
Yeah,
need be.
yeah,
Okay.
because this is a reference angle.
Okay.
But if it's going from pi over 2 to.
Negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2 is fourth quadrant and first quadrant.
Okay.
Yes.
Okay.
Are you adding 180 because that's what it needs to get to second quadrant? or
Totally.
Yeah.
And also because that's how a reference angle would work. So if I'm here and I want to be over there, isn't that pi? Isn't that 180?
143.
So if it was in a different quadrant, you'd add a different.
You'd have to consider how do I get to where I'm supposed to be.
So if it was, if we need to be in the first, we do 90. Question mark.
Well, if the answer was supposed to be in the first, it would have just given me the answer because that's somewhere it exists.
So
Oh, yeah,
Yeah.
okay.
what would you need to add to be in the third one then? Would you need to add?
We'll get to that. Okay, I'll show you. Okay, so real quick, what do we got here? We got, so now I got to add 180 to this, right?
Yep.
So I got 143.13. And of course, R, Mike was saying this earlier, why is R kind of nice? Because this is 3, this is 4, so this is 5. I like it. This time we go, ooh. So, I mean, that one's nice. It's still, the formula is this, of course, but I mean, this just happened to be a triangle. I made it nice. They're called Pythagorean triplets. Does that make sense? Because there are 3 numbers that work well in a right triangle. Okay. So let me give you this. I think this might be, you might like this better. I also have the practice test, but shit's coming hard and fast, right?
Word graph paper. That's, looks like an orb web. I see a spider crawling out.
Sure.
Oh,
We need
One
an
more.
extra one.
No, she's good.
oh, never mind.
Thank you, though. I like that. Looking out for each other. So, like Mike said, this looks like an orb web. I love it. This is one of the better. If you search polar graph paper on Google, you can actually find other ones. This is one of the better ones I found. I think there's actually an even better one, but oh well. So how do I look at this thing? Well,
I don't know.
look at this first point. What direction do I want to face? What angle do I want to turn to?
Pi over 3.
All right. So I always start on the x-axis at the origin looking at 0
Oh, I
degrees.
see.
So I want to turn to pi over 3, and then I want to walk how far? 3.
3.
So each circle could be 1.
Oh, okay.
So this is interesting. Let me see if you can visualize this. I got to find something that would work. If I took the xy plane and I curved it on itself, do you see how the x lines would become these circles?
Yes.
So that is an axis. It's a circular axis. As I step out, R's 1, R's 2, R's 3,
Uh-huh.
maybe?
Yes.
So this is weird. XY axis is easy. X-axis, Y-axis. R theta is weird. The theta axis, you can't even really see it because you just rotate. And then the R axis is curved because as you rotate, you would stay at the same radius. So I want to face this, and I want to go out 1, 2, 3. So there it is. That is the point. 3 pi over 3.
3 would be 1 under, right? Because that little circle in the middle.
Oh, I'm sorry. I missed that. 1, 2. Yeah, thank you. I totally missed that little dude.
Yeah, sorry. I was going to ask you if we should count that little one.
Yeah, the little dude you should count. Yeah.
Okay.
I just went right there. Okay. What about, so take a second. Don't say anything. Can you graph this?
Yes.
Do it. All right, so this shouldn't be too bad, right? You want to face 3 pi over 2 and then go, well, watch. You have to face, let me say this even better. You have to face 3 pi over 2 and then walk forward 4. Do you guys understand that?
Yes.
So I'm not going to go this way because then I'd be walking backwards, wouldn't I?
Yes.
I'm facing 3 pi over 2.
Yeah.
Oh, we're doing it. Hold it up right now.
So face 3 pi over 2 and go forward 1, 2, 3, 4.
Yeah. What happens if it's a negative?
We're getting there. What do you think it means? This one I said walk forward 4. This would be walking backwards, exactly. So how do I do this one? I want to face pi, so I want to face west, right? You can think of it that way. And then I'm going to go 1, 2, 3 and a half. By the way, this scale, the circular scale, you can make it whatever you want to, just like you make an x-axis scale. So I could have made every 2 circles was 1. So I could have went by 1/2. It would have been better, but oh well. Too bad for Jeff.
Wait, so if you were to walk backwards on an angle, what is that?
All right, let's do this one because we're running out of time anyway.
Angle?
So what do I face?
2 pi over 3.
2 pi over 3. Now here's my little trick to do this. So I'm facing 2 pi over 3 and then I'm supposed to walk backwards, correct?
Yes.
So then you start.
So what actually, oh, this is what I did find better because I have one that's actually labeled on this side. This one would be 7 pi over 4 here, right?
Yeah.
And this one's going to be, oh yeah, it goes by 12, that's right. This one would be
11.
11 pi over 6. Sorry?
Why did they put those there?
Put what there?
All of the whole unit circle.
To make it easier to know where to face.
Oh, okay.
Yeah. And then this would be, I'm sorry, this one would be 5 pi over 3. I like it. So I would find, I'm supposed to face this and walk backwards.
So technically,
So I just find the over 3 that's in the other direction and I walk towards it,
okay, so
right? So I'm going to walk towards it. 1, 2, 3. Yeah, this would have been better to make a better scale, but oh well. All right. So obviously I am very out of
okay,
time.
so it would switch the angle or the radius, no, the angle.
So this is the first time we've seen where something we're calling a radius can be negative, and that's because it just means which direction do you want to walk,
Okay.
right? Okay. All right. Oh, practice test. Somebody requested that I post the practice final. Let me if you just
Yes.
email me.
Yes.
Yeah, just
We're gonna need that.
you just email me. I'll post the practice final. I just keep using the same one, so it exists already.